Good day, everyone, and welcome to JK Michael's Knowledge Series. Today, we're going to be talking financial modeling using Excel. We want to understand how to create financial models using simple to advanced or simple to intermediate level Excel simulation. So just follow me and we'll go through an introductory theoretical part. And then after that, we'll go on and do more practicals using Excel so that we can be able to see how we can create models beginning from a pre-existing three statement financial model, which would be the income and expenditure statement, the cash flow statement, and the balance sheet, right? So these are the three statements that we use as a starting point, three financial statements and three financial statements. We have number one, we have the income statement. Number two, we have the statement of financial position, or what you call the balance sheet. Number three, we have the cash flow or statement of cash flow. Okay, so these are the three primary financial statements we'll use as starting points for creating a financial model. There are lots of other models that can be created. In fact, as much as applications are in finance, like NPV and what have you, that's the same way we can have models to be able to address them. But let's begin with the fundamentals of this. So let's move on. Let's look at definitions, very simple definitions. Let's first of all begin with how to build good Excel models as our first module, module one. Now, let's first of all consider what a model is before we even talk about an Excel model. Now, a model is a description, right? Let's call it a conceptual representation or description of real world scenario or events, right? So first of all, a model is not the real thing, but it attempts to represent or describe the real world, right, in a much simple manner, right? Now, one of the very fantastic things about models is that models take what can have a whole number of faces, millions of faces, and then puts it into a very, very simple representation. So conceptual and simple representation or description of what would have been of what would have been of, let's call it otherwise complex real world event. Now, the real world is complex and complicated. If I asked one to describe how many transactions happen in the world today, or maybe in a particular country, let us say Nigeria, you'd be looking at hundreds and billions of transactions happening in a day. But if I say, okay, take all these transactions and show them on a demand curve, I mean, the whole transactions for a year and show them on a demand curve, then what I get is just a very simple demand curve, right? And the demand curve would be a vertical line, a horizontal line, and something like this. And this is a demand curve where this is the quantity demanded and this is the price. Now, this has described everything that has happened in the economy for a whole year, for a period of 10 years, using just three lines. That's why it's a model. What does this model say? that as the price goes up, the quantity demanded, oh, sorry, I did for supply. Quantity demand is actually on the opposite side, right? It's going to be something like this. Sorry, I did that for supply, right? Now, so you can see that as the price rises, then the quantity demanded will reduce, and as the price falls, the quantity demanded will increase. This very simple representation describes millions and billions of transactions that will happen, trillions of transactions that will happen in 1 year, 2 years, 3 years, a decade, probably since the existence of man, right? So what we have done is we have taken what otherwise would have been complex real-world events and described it in a very simple representation. And that is what a model is. And I hope you will find that applicable this principle applicable when we begin to build models. Now, what are the characteristics of models? Well, good models uses should be realistic. Now, first of all, models usually are projections of the future. At least financial models are projections of often what the future will look like. So it's very important that it's realistic. Now, when we're going to have inputs, we're going to have assumptions. For instance, we can assume that the price of the dollar to the naira will be 1,500 on average throughout the year. It's an assumption. It should be as realistic as possible. Because if you decide to make it 1,200 or 750 naira to a dollar just because you want to get a particular outcome, you log in inputs that are not realistic, well, you will get the outcome you want, but it will not reflect, if your model would be less reliable, right? You want to use realistic inputs and assumptions so that you can get realistic outputs that can help your decision making, right? And also, I think that pretty captures it. Now, the next thing is error-free. I mean, these financial models are very simple mathematical models describing relationship between one aspect of a financial statement and another aspect of the same or another financial statement. So you will see an interrelationship between the income statement, the balance sheet, and the cash flow statement. And whatever other model that you might be building, you want to make sure that you are testing, identifying, and dealing with subtle error. If a mathematical model has faulty formulas or faulty calculations and assumptions, then it's not reliable, right? So whatever input we are putting into the mathematical model should be reliable across all the combination of inputs you put in. And then number 3 should be flexible. You don't want an income statement that's just a model that just answers, okay, what happens when if we have our gross margin at 30%, what does that mean for us? Okay, let's increase it to 50%. Well, it's answering only one question, gross margin. There's 1,000,001 other questions that can be answered. And the real world is not reduced to gross margins. So it's very important to ensure that your model can answer a lot of questions, can even anticipate what changes that can happen and be responsive without a major redesign. That's flexibility. And then another thing we want our models to have as a characteristics is, of course, easy to use. You want to have a well-purposed, every financial model should have a purpose and carry what instructions for use. It should be designed, it should be well designed, it should be well labeled, and the input should be properly grouped so that people know, okay, this is what I'm going to go. This is what this model is used for. These are the inputs I need to put in. This is the output I expect to get, and this is the decision I intend to use it for. So you should design a model with the user in mind, and then easy to understand formula, right? So don't make. I always say that in financial modeling, just like in programming, don't use 2 lines where 1 line will suffice. Don't use 10 words or 10 elements where 5 will suffice, except if each of the 10 is needed in a way for understanding so that the user will understand. Because yes, we will expect simplicity. Simplicity should never trump usability. That's very important. Let me apply a little bit of programming principles. There are ways you can write a code to be usable. I mean, to be simple. In other words, it doesn't have excessive words, doesn't have a lot of repetition, and that's fantastic. But it's only fantastic in as long as it is easy to understand and use. So yes, understandability and usability um, easily trumps simplicity. But generally, you want to make it easy to understand, avoid overly complex or long formulas, use intermediate calculations so that it's easy. If there's something people need to understand before they understand this element of the model, make sure that you show it in an intermediate calculation. Use short descriptive cells and name ranges, right? And this can help, right? Creating a name range or describing in the cell, which is something I always do. And then use VBA, right, for deeply nested and logic that's expected to repeat itself. Judicious formatting. Use formatting to improve clarity, right? If there are things you need to label in a particular column or with a particular font because of the role they play, right? Make sure that you format it for easy use, right? Don't do excessive styling. It's not a fashion show. Don't do excessive styling. Keep it very simple and not distracting, right? And then for numbers formatting, you want to use minimal decimal places, right? It's not a standard normal 4-figure table. This is a simple Excel sheet. Most financial statements are, or most finances can be represented to 2 decimal place, right? And of course, for heavy numbers in finance, we usually knock off 3 or 6 zeros so that we can have a more concise version of the numbers, right? So yes, apply thousands or millions formatting when suitable. That's knocking off 3 zeros or knocking off 6 zeros. And make sure that there is uniform formatting. If you have the same numbers that are classed as the same thing, maybe your income statement, you don't need to make any differentiation, any specific differentiation, then you use similar um, formatting. And then we have try not to hard code numbers. If you hard code numbers, when changes happen that should affect, so in Excel, in a spreadsheet, if you make changes in one cell, depending on what it's linked to, it's likely to make changes reflect in other cells. But if in the act of transferring the value from one point to another, you decide to hard code, or if in writing your formulas you hard code, then you would have difficulty when an element is changed somewhere that should affect a particular area in your spreadsheet. So avoid embedding values in formulas and treat changeable values as variables because, of course, they can change, right? And then cluster inputs and output logically. If there is a part where you need to make an input, and then there's going to be another area of the spreadsheet where you expect to have an output. Let it be clear that these are inputs and these are outputs, right? Whatever analysis you want to have, any breakdowns, you want to put them in modular or an attached sheet, an adjacent sheet. Try as much as possible to include clear titles, headings, and labels. And if you have key results, you want to provide the summary section, right? A lot of spreadsheets, a lot of models have what you call a summary sheet, and it uses that to be able to display all the major highlights of the model. And then moving on, we have good output production. Now, what does this mean? Clear and persuasive outputs. You want, again, it's very important that your output should be usable. It should be simple to understand. It should be easy to use. It should be easy to communicate. So yes, you want clarity and what persuasive outputs. You want easy to produce inbuilt reports, right? Information should be clean and hierarchical, right? And then use charts where appropriate. A good model also has what? Documentation for very important or non-trivial model. If there are documentation that should guide how people should approach, use, or handle this model, then you want to make sure that you have your documentation properly put down and very visible, very easy to understand, right? And then, of course, we have data validation. Check incorporates what? Good checks to ensure that what? Input errors are not there. So if you need to validate data or say, let me explain what this means. Now, if you use just a part of the spreadsheet you call data, and if you dig down into that section of the spreadsheet, you see data validation. What it does is that it specifies the kind of inputs that can enter a place. So it could say, okay, only numbers should be here, or only lists should be here, or only this class of data should be entered. Well, it's very important if needed, especially when you want to minimize input errors, right? You can use data validation as a tool. And then we have documenting Excel models. Now, we've spoken about documentation. Now, a very high chance is that there's a very high chance that your model will not be used solely by you that created the model, but it will also be used by other people. Now, if your model is going to be used by other people, then it's very, very important that it should be transferable, right? So yes, when it's transferred, you want your model to be able to explain to the other person what your model does and how it works. You want the documentation that describes the structure, the assumptions, and the data that have been imputed in the model. You want your model to be efficient and show if there will be future, enables what efficient use and helps the person to make updates going forward, because a lot of times models, assumptions can change, and the user might decide to test a different assumption on the model. So yes, future updates should not mess up the whole dimension of the model, or should what? Work closely with the model. And then it records what? Shortcuts, temporary fixes, and assumptions that need revisions. This is the purpose of providing documentation. Now let's look at what the general principle around this would be like, right? There is no standard documentation format. And so nobody says, your documentation must take this form or take this size or must be this long or must be entered in this font. No, right? Documentation style will evolve over time. And a lot of times you should look for if there are organizational standards or just something that will make it easy or simple or very usable. That's what you should aim for, right? Compliance and usability. So compliance is if there is a way the organization already represents its model, then you should comply. And then it should also be usable, right? Now, the level and method will depend on the use or the objective of that model. Now, moving on, right? Ways to document your model. Self-documenting design, right? You want to have clear structure and organization, right? You want to have well-described titles, labels, footnotes if necessary. You want to have cell range and naming your ranges. You want to have short readable formula. You want to be able to display and print formulas with row and column headings, right? And then you want to have a printable list of cell comments and name ranges. So these are all some of the ways you can be able to properly document. It's unfortunate I can't really show a lot of these things because I don't have a spreadsheet projected down, but hopefully I'll be able to do that as we progress with the modeling exercise, right? There should be space for assumptions, inputs, and outputs, and they should be properly grouped, right? If we have assumptions, then the assumptions should be highlighted and properly labeled. Your inputs, when entered, is supposed to generate some sort of output. Well, they should be in a labeled area so that it can be clear that we're looking at an assumption. It can be clear that it's a place where we need to make a certain kind of input, right? Probably with a labeling of the kind of input that is required. And then it should be clear where we expect to have what output. So explanation should be placed near relevant inputs, and your output should be clearly identified and very easy to interpret. Now, again, you can have what cell comments, right? Can be used as a secondary layer documentation. So while the other while the other documentations might be on the main sheet, right? Now you can also label, and I do this very, very extensively, right? You use that as a secondary documentation layer. You add it during model development. It's limited to stable information. If and information is likely to change a lot, then you don't want to make a comment on the cell that would become irrelevant when that particular cell activity or that particular cell element changes, right? And then we have what? Model description. You want to have a dedicated worksheet for non-trivial model, right? So I want to do a forecast and then have NPV, internal rate of returns, and so on. Those are very for major projects. Those are of significant concern, and you want to make sure that you have a dedicated worksheet for them. You don't want to mix this and probably the three income forecast for the next year. Just bundle everything up in one sheet. That would not be a very, very sound, very good practice, right? You want to describe every model's purpose, the operation, the logic, and what it depends on, interdependency, what it relates to, what it depends on, what it works closely with. We have very important, and then we have version description. Now, okay, it's very important to note that we could have many different versions, and you're going to see us create from one model, we're going to create multiple versions of one particular model, right? And it's very important that you should be able to separate a version from another version. Why are different versions created? Different versions are created to be able to simulate changing scenarios, right? So you could assume one thing and then an assumption may change, or maybe we get to an upper limit or a lower limit of something and we need to take a different kind of action. Then we could also simulate what that secondary level of action will be, right? So dedicated worksheet login version, dedicated worksheets logging version numbers and major changes, right? Your version would expect, your model will be expected to change in its version probably continuously as long as you're developing. And then you want to make sure that you can be able to track every change that was made and know which changes, right? And what those changes mean for all the versions. And then we have other documentation, right? For very large models, you might need formal documentation, documentations that may even be out of the spreadsheet, right? Maybe in a Word document, make sure that it's very simple, very well described, might include things like objective, rationale, flowchart, and the user manual, right? So again, you're seeing what we're talking about is what ensuring that what you consider the usability of your model. That's the most important thing, that it is usable. What's the purpose of debugging? You use debugging to what? Identify and fix errors in the model, right? So let us assume that things go wrong in the model, wrong formula was used, or maybe we did not properly check the box, the iteration box, right? All of these things can bring about, problems, errors in the spreadsheet. It's very important that we debug. Debugging a model, just like the way you debug code, is very, very vital, very, very important, and provides opportunities to run some sort of quality checks, quality assurance, and make sure that indeed this model has integrity and it does what it promises to do, right? It improves accuracy and reliability, and you need to systematically and thoroughly search. You need to comb your model to be able to identify errors, right? Now, how do we debug? Well, first of all, search methodically rather than repeatedly checking the same areas. So know what you want to deal with, know the areas where you want to search for errors, right? And then go into these places and make sure that you check all the boxes, check all the places that are likely to carry errors, and then ensure that it's clean. The right inputs are in, the right formulas, the right outputs in the right location with the right description, and you're good to go. You want to trace backward from obvious errors. If there is an obvious errors, then you want to see, okay, what might have caused it? And then you do a little bit of root cause to be able to trace the original error, right? And then you want to break the model into logical components for testing. For instance, if an error appears on the third sheet, then you can decide to break it into three and then analyze the first, the second, and the third in depth to be able to see where the errors may have come from, right? You also want to verify each component before moving on to create another model and distinguish, also be able to understand the difference between obvious errors and very subtle errors, right? Now, for obvious errors, right, errors Excel may find for you will pretty much be obvious. The syntax is going to make it very clear that this is an error, right? So if it may be detected during entry formula. So there's a way I'll type a formula and the Excel spreadsheet will tell me, no, you did not put a comma, or I think you put double commas, or you were supposed to do this, right? Or probably would just give me an error message, right? So if Excel is detecting that there is an error or suggesting a correction or suggesting fixes that should be reviewed to be able to improve your logical calculation error, your logical calculation order, then that's Excel helping you with more obvious errors. And let's look at some of these things, right? Of course, you can see this. Most of us have seen or familiar with some of these errors, right? So this means that the cell is too narrow to display the result. What you usually will need to do is to double tap at the edge of the cell and it will expand, right? We have this. It means that you have an incorrect argument or operand type. Operand is your plus, minus, multiply, or divide, right? Incorrect argument. Of course, when you divide anything by zero, it gives you zero. There are ways to handle this so you don't have a div error, but a plain sheet, right? Name is what? Asterisk with a name is an unrecognized or misspelled name, or missing quotation mark, or deleted names. Of course, this is where the reference value is not available, right? This is an invalid cell reference due to deletion. This is what an invalid numeric value, a calculation issue. And this is an invalid intersection of what? Non-overlapping ranges, right? Spelling mistakes can be detected not by the numeric aspect of Excel, but through the spell check feature. But mind you, that spelling mistakes will not affect your calculations, that can affect or negatively impact your interpretation. So if a spelling mistake is consistently, if a spelling mistake is consistently applied, then Excel, like, if a spelling mistake is consistently applied, it would likely not, for instance, if I want to use the count, if I want to use the count for a particular word, well, as long as I apply the wrong, I use the wrong spelling consistently, then the count has no way of knowing that I used the wrong word, right? But generally, with respect to human interpretation, the people who would use the model and for use of the Excel, the part where it interacts with letters and words, right? You might want to make sure that you pay attention to spelling and use the spell check. Right? Check for visible and hidden content, including comments and chat elements. A lot of times this happens after you duplicate a sheet. You duplicate a sheet and there are comments and chat elements that are hidden, right? And so, for instance, a lot of times I put a comment on the cell and I duplicate the cell and well, the comment is still there in the duplicated cell, and I have changed every other aspect of the cell, but the comment, and I have a special way I enter my comments that is not, and I'm going to show that because it's something that I would like people to use if in case they don't already use it. But then again, for subtle errors, you will often have to find these ones yourself, right? General characteristic automatically would not be detected by Excel, often subtle and harder to identify, and requires what? A systematic review and understanding of what you're using the model for. So if you don't understand, if you don't have what you call subject matter expertise with respect to the model you're building, it's very easy for these errors to escape, right? So let's look at some of them. Errors in the financial or the mathematical aspect of the problem, right? If, for instance, you are calculating you're creating an income statement, and there is a way we calculate net profits, but it will require putting minus and minus and minus. And I'm going to show us when we get there to be able to have minus on every expenses. And there are ways we would have it that we don't need to put in minus. We just use sum and then we calculate everything in it, right? Now, if we did that, if you don't understand how or why we do it that way, you're likely to make mistakes. Right. Another thing that can bring about mistakes is when you're applying the additions and the subtractions in the cash flow statement. This, if you make errors there, it's going to be subtle and it would not be very easy to note it. And I'm going to show us where all these errors can come from. Right. So if you use an incorrect financial or mathematical logic, then you're going to have one of these kinds of errors. Right. They require ability to solve the problem correctly outside Excel. You need to understand the mathematical logic because Excel will not even be able to detect that something wrong happened, right? You need to detect it by validating results and sensitivity to impute changes. Let's look at, right? Now, errors in translating a solution into model. So when you're converting a correct logic into Excel formulas, then mistakes can be made, right? One very popular mistake I used to make at a point was how and when to use, when I was starting out, was how and when to use what we call parentheses, which is the brackets, right? You would notice that if you don't rightly apply your brackets, you can have the right mental calculations, the right mental logic, but you'd have a problem with getting the right output, right? Include formula construction and logical translation errors, right? And you can identify through a step-by-step review of the components of your model. And then another problem is what you call a circular reference, when a cell is referring to its own results, right? And we're going to see very simple examples of circular references. So when I say 1 + 1 is equal to 2, then I've created a result. When that formula goes back to depend on the 2 that I've created as a result, then I've created the circular reference. Can be intentional, right? And we'll have a lot of intentional circular references. They are not always an aberration, right? And when we create intentional circular references, we will go and turn on an iteration feature, and I'll show you how to do that. But a lot of times it's accidental and it will show an error on your sheet, right? It would point out the areas where there are circular references so that you can make adjustments. Requires careful control of the iteration setting. Like I said, you go to the options, the iteration, and you check the box on or off, and it will influence how Excel will approach or treat your circular reference. Unintended circular references must be avoided. If it's intentional and it has a purpose, then very good, we can use it. Now, another error you would expect to find is what? When using wrong names or cells address in formulas, right? So if you have an incorrect name range or cell reference, then, well, you will need to detect it yourself because it will not be flagged if the name or reference is valid but incorrect. What Excel will likely flag off is an invalid name reference, right? Name or reference. If it's incorrect, in other words, maybe spelled or if you were supposed to put in MPV, but you put in IRR, well, it will not correct it because it's actually valid, right? But not suited to that particular discussion. Includes what? The use of what? Relative, absolute, or mixed references, and requires what? Careful formula entry, review, and auditing tools. And then moving on, we have using the formula auditing tools for debugging. There is a formula tool that a formula audit tools that helps us to be able to debug and find errors. It helps us to be able to trace or identify errors in large, complex model. Helps us to be able to systematically find errors and debug them based on what? Showing us what the formulas and the dependencies. Right, we have things like what? Zoom. It adjusts the magnification so that we can be able to view, zoom in more or less on the worksheet. Use it to be able to inspect large areas or detailed sections while you are debugging. And then we have go to special and select cells based on specific criteria. You want to be able to locate or identify areas where there are formulas constant or missing formulas. You want to be able to isolate the relevant cells so that you can take the right action. And also we have the auditing formula tools. You'll find under the formula auditing tools, you find the cell precedents, right? So some of the things you need to understand is what cell precedents is cells that contribute to the results, can be directly or indirectly. And then we have what cell dependence, cells whose results depend on a given cell. Again, can be direct or indirect. And then we also have and then how do we use this, right? The formula auditing tools. Identify whether an error comes from a formula or from its input cells. Provide a graphical tracing. Helps us to be able to trace the dependents and the precedents. And we use the auditing tools menu or toolbar, right? In the formula section. And then, so we have what? Trace dependence. Now, the trace dependence displays cells that feed into the selected formula. Helps us know, it reveals what? Multiple dependency levels incrementally. We have what? That's trace precedence. Trace dependence displays cells affected by the selected cell. Is useful before making changes to inputs or assumptions. You want to know the dependents, what are likely to change when we change this cell, right? Remove arrows, right? It removes the precedent or dependent arrows selectively or entirely. And of course, we have trace errors. It highlights cells that may be causing a display error. We're going to have an opportunity to look at some of these when we begin to do our spreadsheet model. Additional debugging tools might include display the formulas instead of results so that you can review logic. So there's a formula display tool that allows you to be able to see what the formula is, and it's not the logic, it just displays the formula. The dependent and the precedent show the logic, right? But you could also ask to see the formula, right? You want to see whether you want to toggle between formula view and normal view as needed. You can do that. And then you can use the zoom to improve visibility when tracing dependence, right? And these are debugging tools. Now, learn modeling using Excel. Why is this important? Gives you an opportunity to learn faster by working through models systematically, right? Gives you an opportunity to study the model building process, not just completed models, right? Why it's very important to learn this through Excel. Uses what theory review section where we are not able to understand the formulas, right? And then master Excel features before you apply them in complex models, especially in our fundamentals, the beginning sections of the class. You're going to follow the standard modeling steps consistently, and over time, you develop a modeling style with time, starting with the examples we're going to use. So this is just the approach you should take when you are learning, right? We're going to create very, very simple models, and from simple models, we're going to go into more complex models, right? And then you can learn, make mistakes, and then improve on them, iterate, right? Continually improve. Now, there are 4 learning tracks, right? Now, the 4 learning tracks will let you know ways you can be able to learn Excel, each one with decreasing difficulty. Of course, as you learn at the base and you improve, you would notice that you would start learning, your assimilation will become faster, better, and easier. You want to choose the most challenging learning track without excessive frustration, and it allows you to be able to track differences related to the model building stage. So if you want to learn how to build spreadsheets on Excel, how to build models on an Excel spreadsheet, there are 4 ways or 4 approaches that you can use in learning or mastering Excel. Right, so let's look at the learning track, which is what? Learning track 1, that's the most challenging. You want to build the models independently from problem statements. So one of the things we're going to do throughout the Excel training or throughout the model training is that we're going to give you a problem statement, and you'll find a way to apply modeling, both financial principle, mathematical logic, and modeling understanding or spreadsheet understanding to be able to solve the problem, right? You retain only necessary data when starting, right? In other words, you're pretty much building from the ground up. Refer minimally to sample solution, and then you compare your final model with the solution after completion. Is best followed in sequence as later models will build on earlier ones. Now, there's also this is going to be more challenging, but you might find your learning very complete if you did this. This is almost like building from the ground up. Learning track 2 is that you would retain the model structure when removing formulas for a new model, right? It's used as a what? Modeling strategy and theory review. Uses modeling strategy and theory review as guidance. Builds model independently following standard modeling steps, and you compare your completed model with your sample solution. And then learning track 3, you will retain the model structure and its labels. You use your modeling strategy and the review of the theory. You complete early modeling steps independently. Then you follow step-by-step build instruction for completion. And then the least challenging track 4, review completed models directly follow provided step-by-step instruction, and then focus on understanding the rationale behind each steps, right? And so we're going to go on into the second module, which is financial statements forecasting. So this is where we're going to begin to build our models. Now, how we will do it is that we're going to build the basic models, right? We're going to create a very simple 3-statement model, right, of pre-existing years. And then based on that, we would run ratio analysis as a starter. And then when we're done with ratio analysis, then we'll begin to forecast. And how we will do it is that we're going to create new, we're going to duplicate previous models. If they are going to, we're going to apply maybe slight changes to a principle, we're going to create a duplicate. In other words, we'll start from maybe if we created model 1 and it's usable in model 2, then we're going to duplicate the model 2. We're going to make a couple of changes, right? Changing in the labeling, and then we'll go on to prepare the model, make changes to the formula, right? And that is what financial forecasting, right? So let's get ready, right? And I'll see you in the next video where we'll begin to discuss how we can forecast financial statements. Thank you for being a part of this class, and I'll see you in the next video. Bye for now.